In this video, we're going to take a look at different ways that we can represent polar coordinates. So we'll begin with an example. In this example, we are being asked to identify the polar coordinates of certain points. We are being given a polar graph, and on that polar graph, we see that there's a point A in the first quadrant, a point B in the second quadrant, a point C in the third quadrant, and a point D in the fourth quadrant. How can we identify those points? So we want to determine those positions, and we're being given some choices here. So the first choice is the polar coordinate -3, negative pi over 6. Where is that point? Is that point at A, B, C, or D? So here's how we go about this. We're going to start by identifying where negative pi over 6 is at. Negative pi over 6, first of all, let me just say, if I look at the way, there's a lot of angles on this, I think that the A, the B, and the C are all at multiples of pi over 6, so we can go ahead and make that assumption. It looks like A is sitting at 1 pi over 6. It looks like B is probably sitting at 5 pi over 6. 5 pi over 6. C is at, what would that be at? 7 pi over 6. And D is at 11 pi over 6. Those are the positive angle measures. So negative pi over 6 is going to be from the polar axis, going clockwise. All right, so it's going to be here in the same position as 11 pi over 6. And we're going to draw a directed line segment on that angle measure. But because our radius is negative, we're going to draw that directed line segment directly across and mark out 1 and 2 and 3. And so we can see that that angle measure of negative pi over 6 that put us in the fourth quadrant, because the radius is negative, it takes that fourth quadrant point and moves it directly across to the second quadrant at point B. All right, let's look at another one. 3, 5 pi over 6. Well, 5 pi over 6, I'm going to change to a different pen color. 5 pi over 6 we know is in the second quadrant, and we already have a directed line segment there. And so now we just need to go to a an angle or a radius of 1, 2, and 3. It's a positive 3, so we're going to stay on that side, and so it looks like this one is also at B. So two different ways of writing that point. Let's look at a third one. Where is negative 11 pi over 6? Negative 11 pi over 6 is starting on the polar axis, and then it's going clockwise. So going clockwise, and I'm at 1, 2, and 3, aren't I? That's going to take me all the way around to the first quadrant. So let me just write here that 1 pi over 6 is the same location as negative 11 pi over 6. And I know that that's true because if you think about negative 11 pi over 6, if I were to add 2 pi to that, right, that's a full rotation. 2 pi is 12 pi over 6. So a negative 11 pi plus 12 pi would give me 1 pi, wouldn't it? And you've learned this in previous videos, but it feels like it's always something that comes up as a confusion. So I'm going to draw a directed line segment at negative 11 pi over 6. And then because my radius value is positive, I'm going to stay in that quadrant at 1 and 2 and 3. So I'm at point A. Let's try another one. 5 pi over 6 is the angle measure on this one. The radius is negative 3. So we've already identified where 5 pi over 6 is. But now, because we have a negative radius, we're going to go directly across to 1, 2, and 3. So we started in the second quadrant, but that negative radius takes us directly across into the fourth quadrant at point D. First time we've seen point D. Let's keep going. How about the point -3, pi over 6? So one way to think about this is, we know that pi over 6, right, is in the first quadrant. And with that negative radius, we know that we're going to go directly across into the third quadrant. So that directed line segment has to go directly across to 1, 2, and 3. So we are at point C. And I bet if you were asked what's another way of writing point C, the fact that C is sitting in the third quadrant and it's sitting there with this angle of 7 pi over 6, I bet you could easily maybe come up with another way of expressing that. And maybe we'll see that here in a second. Ah, there it is. Okay, so here we have an angle measure of 7 pi over 6, but we have a positive radius, so that means we're going to stay in the third quadrant. So this one's also going to be C, isn't it? How about -3, 7 pi over 6? So we know we're still sitting at 7 pi over 6, but now we have a -3, so we're going to move from the third quadrant, right, quadrant 3, we're going to move across to quadrant 1. And so that's going to put me in the same location as point A. Let's keep going. And I think this is the last one, -3, 11 pi over 6. So 11 pi over 6 is in the fourth quadrant. And because that radius is negative, we're going to move from the fourth quadrant into the second quadrant, and I'm going to be at point B. So let's summarize some of the things that we did in that last example. We talked a lot about when the radius changed to the opposite sign, that we had to move to the opposite side or the opposite quadrant. We can say that a little bit more concisely with math. And here's what I mean by that. If you're being given a point with polar coordinates r, theta, we can represent that polar coordinate by either of the following ordered pairs, where k is an integer. Okay, so if the r value that you start with stays as an r, but you want to write it in a different way, well, you can take the theta that was given to you, and just add or subtract multiples of 2 pi, right? I could add 2 pi, or take away 2 pi, and that would keep me in the same quadrant. If, however, the radius is being asked or is being given as a negative radius, or the opposite, I should say, then what you do is you take that theta and you move to the opposite side. Now, the way you move to the opposite side is by simply adding pi to it. Or if you're in degrees, you would add 180 degrees. Now, that's usually good enough, but if they want you to make that angle even bigger or even smaller, then you can add multiples of 2 pi or take away multiples of 2 pi. What we saw in the previous example, we had a k value of 0 here, so we didn't have to really worry about doing anything beyond just adding pi to it, okay? I'm going to erase that though, because that's not always the case. All right, so let's take a look at an example. First thing they want us to do is plot the point 4, 3 pi over 4. So let's do that. So 4, 3 pi over 4, we're going to first locate 3 pi over 4, and that's in the second quadrant. And then from the polar axis, we're going to draw that terminal side of 3 pi over 4 as a directed line segment. And because my 4 is positive, I'm going to stay, 1, 2, 3, 4, I'm going to stay in quadrant 2. And one thing I just want to say, because this becomes a little bit confusing to people, is if I want to write that point in multiple ways, I simply have to make sure that once I think I've got that multiple way, that it still lands me in the second quadrant. Okay, so keep that in mind. We're staying in the second quadrant. Okay, so The next part of this says, find 3 other sets of polar coordinates that meet the following conditions, but mark the same location on the graph. Okay, so part A says that I want to have a radius that's greater than 0. Well, my radius of 4 is already greater than 0, so the 4 is not going to change. What is going to change is that my theta needs to get larger. Okay, so here is what we said before. If the radius is not going to change, but we want to write this polar coordinate in another way, then all we need to do is just take whatever theta was given and either add multiples of 2 pi or take away multiples of 2 pi. Now, they want my theta to be bigger, right? They want it to be between 2 pi and 4 pi. So I'm going to take that 3 pi over 4 and I'm going to add a multiple of 2 pi. I don't think that I need another multiple of 2 pi. My k value can just be 1 in this case. So that becomes the ordered pair, 4 comma. What is 3 pi over 4 plus 2 pi? Well, 2 pi is 8 pi over 4. So that becomes 11 pi over 4. That's what I think it should be. Let's see if I'm right. If I start at the polar axis, if I start on this polar axis and I go around to 3 pi over 4, and then I add a whole other rotation, so I'm going all the way around to 2 pi, sure enough, I do end up in that same location. So that one checks. Let's do part B. Now part B wants us to have a radius that's less than 0. So instead of 4, I'm going to have a radius of -4. Okay, so that's the example where we're given some radius, but now we're being asked to write the radius as the opposite. So what do we need to do? Well, that's the scenario where we take whatever theta was given to us and we're going to add pi to it. That's what I would suggest you do. Let's start with that. So I'm going to take 3 pi over 4 and I'm going to add pi to it. Let's see if that's good enough. That's going to give me -4 comma. Pi is 4 pi over 4, so 4 pi over 4 plus 3 pi over 4 is 7 pi over 4. Now, does that meet the requirements of the r value being less than 0? Yes. And does that meet the requirements of the theta being between 0 and 2 pi? I think so. If it didn't, then that's where I would then come in, because this is what I've done so far. I just took the theta and I added pi to it. If I need it to get larger, then I would just take that 7 pi over 4 and I would add 2 pi, or if I needed it to get smaller, I would take away 2 pi. But I think I'm good. So let's just make sure that this is correct. So I'm starting on my polar axis, and I'm going to go around to 7 pi over 4. 7 pi over 4 puts me in the 4th quadrant. I'm going to draw the directed line segment, but now that I have that negative radius, I'm going to draw that directed line segment across into the 2nd quadrant, right? 7 pi over 4 was in the 4th quadrant, and that's going to land me where I want to be in the 2nd quadrant. So I like that one. That one works good. Check. Okay, the last one, part C. I want a radius that's greater than 0. Great. I like it when the radiuses stay, because I know if it started as 4, it's going to stay 4. But now I want the theta, it looks like I want it to be a negative value, because it's got to be between -2 pi and 0. Okay, so what you saw me do on part A, I needed it to get bigger, so I added 2 pi. In this example, I want it to get smaller, so I'm going to take 3 pi over 4, and I'm going to add to that 2 pi times -1. That's a k value of -1. That's really like me taking away 2 pi, isn't it? So that becomes 4, comma, what is 3 pi over 4 minus 8 pi over 4? I think that is 4, comma, -5 pi over 4. Does that sound right? Let's see if it is right. So if I start on that polar axis, and I go to -5 pi over 4. So that means I'm going to travel clockwise. So I'm going to go all the way to -4 pi over 4, -pi, and I'm going to land in that second quadrant, and I'm going to draw my directed line segment like you've seen me do, and because this 4 is a positive, I'm going to stay in that second quadrant, which is exactly where I want it to be. So that is how you go about writing a polar point in different ways with different conditions.